Okay. So we have seen different kind of examples. So we will continue. We'll see one more, like few more examples, not one more, few more examples to understand that concept. So let's say again we have a mass of 4 kg, and it is connected with string to the mass of 6 kg. Okay, and let's say we have applied force of 100 Newton. So of course there will be tension in the string. Let's say it is T equal to T. So the question is like find out what is the value of T. Okay, find out T. So in this case, if we see the net force acting on, let's consider this as a complete system. So when we are applying some force, the whole system will move together. Okay, so net force which is acting on this system is 100 Newton. So and if we find out the net mass, so it is equal to 4 plus 6. So net mass in this case is equal to m1 plus m2, that is 4 plus 6, that is equal to 10 kg. Net force in this system is equal to 100 Newton. Therefore acceleration of this system is equal to mm, force upon mass, because F equal to ma. So acceleration is equal to 10 meter per second square. Okay. So both the masses are moving with acceleration 10 meter per second square. Now consider the mass of 6 kg. We'll consider its FBD. Okay. So if we see the horizontal forces acting on this 6 kg mass, then there is a tension T, then there is a 100 Newton force which is pulling it, and since it is having some acceleration, okay, a, which is equal to 10 meter per second square. So we know that F is equal to ma. So basically summation of F basically equal to net, like addition of forces is equal to mass into acceleration. Here, since body is moving in this direction, we will consider forces is in this direction as positive and forces in opposite direction as negative. So what we got here is 100 minus T is equal to mass is 6 kg into acceleration is 10. So 100 minus T is equal to 60, and therefore T is equal to 40 Newton. Okay, so this is how we can find out tension in the string when like both the masses are attached with string and there is some force acting on whole system. So instead of two masses, we can consider the example of more number of masses. Okay, so let's again we have this is ground. So this mass is, let's say, 1 kg. Then there is a string. This mass is 2 kg. Then again there is a string, and this mass is 5 kg, and one more string, and last this mass is 2 kg. And net force acting is equal to 200 Newton. So since there are three strings present in this case, the tension in all strings will be different. So let's say this is T3, this is T2, and this one is, let's say, T1. Okay. So tension in all strings will be different because there are three different strings. So again here we can see net force acting is equal to on whole system. If you consider this whole system, the net force acting on this whole system is equal to 200 Newton. Mass of this system is basically 1 plus 2 plus 5 plus 2. So it is equal to 10 kg. And therefore acceleration is mass, basically force upon mass, that is equal to 200 upon 10, which is equal to 20 meter per second square. So every mass is moving with the same acceleration, 20 meter per second square. It cannot be different. Both it will have same mass, same acceleration. If if any one of them has different, sorry, they have same velocity and same acceleration. If any one of them has different velocity, then the string will break. Okay. So now let's draw the free body diagram of this rightmost mass, which is 2 kg. So, okay, sorry, I think. Oh, so for this 2 kg mass, 200 Newton is acting towards right. There is acceleration of 20 meter per second square towards right. So then let's consider forces in this right direction are positive, forces in left direction are negative, and then there is a tension T1. Okay, so if we do summation of forces, it is equal to 200 minus T1, and acceleration is 20, mass is 2. So F equal to, that is 200 minus T1 is equal to MA, that is 40. And therefore we got T1 is equal to 160 Newton. Okay. Now we will move on to the, so we got T1 as 160. Now we will move on to the second mass, which is 5 kg. Okay. From right hand side. Okay. So now let's move on to 5 kg mass. So in this case, there is T1, which is 150 Newton. On left hand side, the tension is equal to T2, and it is also having acceleration of 20 meter per second square. So again, if we draw summation of forces, and same notation will use, positive force is positive if it is towards right direction, and negative if it is towards, let's say, for summation of forces is T1 minus T2. So it is equal to 150 minus T2, and m is 5 and acceleration is 20, so F equal to ma, so 150 minus T2 is equal to 5 into 20. So T2 here is basically 150 minus 100, so it is equal to 50 kg, sorry, 50 Newton, sorry, it was 160. T1 was 160. I think I made a mistake. T1 was 160, so it will be 60 Newton. And for T3, we will have to draw the free body diagram of mass of 2 kg. And in this case, T2 is acting 60 Newton in this right direction. Then there is on left direction, there is T3. Again, it is moving with same acceleration. So here, basically, we can directly write T minus 60 minus T3 is equal to 2 is mass into 20 is acceleration. So 60 minus 40 is T3, and T3 is equal to 20 Newton. So this is how you can solve this kind of question. I will just give you one question to solve, and I will give you 2 minutes. Let's see whether you are able to find it correctly. So this is a ground. Then there is a mass of 9 kg. There is a string. There is a mass of 4 kg. Again, there is a string. Then there is a mass of 2 kg. Again, there is a string and a mass of 5 kg. There is a force acting towards right, which is 100 Newton. There is a force acting toward the left, which is 300 Newton. So find out first acceleration of the system, or acceleration of each mass. Then find out, let's consider the tension in these strings. This is T1, this is T2, and this is T3. So find out T1, T2, and T3. So both of you got the question. Okay, so please try to solve it. You have 2 minutes to solve this question. Vaibhav, please check it once again. I think you should you should read it properly. Okay, Harini got the answer. Vaibhav, are you still solving or? Okay, okay. Take 1 more minute. Uh, okay, I think, do you want me to solve or you are still solving? Uh, I will solve this question and I will give you one more to solve. Okay. So I think that will be better. Mm. Okay. So here, if you see the total system is basically this is total system. Like in this case, this is our total system. Okay, where all masses are connected with the help of strings. So total mass, if we find out, it will be 9 plus 4 plus 2 plus 5. So total mass M will be equal to 9 plus 4, 13 plus 2, 15 plus 5 equal to 20 kg. And there are two forces acting on the system, 300 Newton in left side, 100 Newton in right side. So net force is basically 300 minus 200. So it will be 200 Newton in left side because, okay, now let's consider since 300 Newton, the higher force is towards left. Let's consider forces acting in left as positive, forces acting in right as uh, forces acting in right as negative. So in this case, net force is summation of forces, that is 300 minus 100, it is 200 Newton. So you get acceleration of force upon mass. So it is equal to 200 by 20 and it is equal to 10 meter per second square. So this is the acceleration, and since the force in this left direction is higher, acceleration is in this left direction only. Okay, it is in direction of force only. So now we have acceleration which is equal to 10 meter per second square. Okay. The next thing is, now let's consider this mass of 9 kg. We will consider this FBD. So for this mass of 9 kg, there is force acting of 300 Newton towards left. There is acceleration towards left of 10 meter per second square. And there is a tension which is acting towards right, which is T1. So since we are, so summation forces, since we are considering this time forces in left as positive, 300 minus T1, then mass is of course 9 kg it is given and acceleration is 10. So if we apply F equal to ma, we will get 300 minus T1 is equal to 9 into 10, which is 90. So T1 is basically 300 minus 90 and it is equal to 210 Newton. Okay. Similarly, now we got T1. Now if you go to second mass, okay, what is second mass? It is 4 kg. And there are two forces acting. One is tension on left and the other is tension on right. So there is mass of 4 kg here. There is tension T1 which is acting towards left, tension T2 which is acting towards right. Then there is acceleration which is acting towards left of 10 meter per second square. And now if we find summation F, it is T1 minus T2. And therefore summation F is force is equal to ma. So T1 minus T2 is basically, m here is 4 into acceleration is 10. T1 we found out was equal to 210. So 210 minus T2 is equal to 40. So T2 is basically equal to 170 Newton. Okay, we got T1, we got T2. Now we will consider 2 kg mass where left side T2 is acting, on the right hand side T3 is acting. So this is 2 kg mass. There is force T2 on left side. There is force T3 on the right hand side. There is acceleration of 10 meter per second square towards left. So in this case, summation of forces is T2 minus T3, and T2 is already known, 170 minus T3. So and force equal to ma. So m here is 2 into force is acceleration is 10. So therefore T3 will become 150 Newton. Okay, so we got T1 is equal to 210, T2 is equal to 170, T3 is equal to 150 Newton. So both of you got it, or okay? Harini, you got this, or have you done any calculation mistake, or what? I think you have done. Maybe you have done some. Okay. Oh, okay. Okay. You have added that forces. Okay, but they are in opposite direction, so therefore you cannot net forces for finding net forces. You will have to subtract it. Okay, I will give one uh, similar question, so it will help you in underst understanding it properly. Okay, it is straightforward question. Just give 2 minutes. Okay, there are two masses which are connected with single string. One is 20 kg, another is 10 kg. So here force is acting 100 Newton, which they are connected with a string. So there is tension T inside the string and force 40 Newton acting towards left. So now find out acceleration as well as tension. So you have 2 minutes to solve this. If you have understood the last question, this will be much easier for you to solve. Okay, please try to solve this question. Okay, acceleration is 2 and tension is 60. And you got acceleration as mm, 2 and tension is 80. We'll see the answer. Okay. So here, mm, okay. So if you consider this system, total mass of this system is 20 plus 10, that is equal to 30 kg. Okay, total mass. And net force, if you find out, 100 Newton is right towards right, 40 Newtons towards left. So since more force is acting towards right, let's consider this as a positive. Like forces in x right are positive, forces in left are negative. So net force you will get equal to 100 minus 40, that is equal to 60 Newton. Okay, so 60 Newton is the net force you got. Now to find, since 60 Newton force is net force acting towards on the system acting towards right, of course the direction of acceleration will be same towards the force. Okay, so I just Okay, this 16 Newton net force is acting and acceleration is this. Therefore, acceleration is force upon mass. So force is 60, mass is 30. You got acceleration as 2 meter per second square. Now consider this 10 kg mass here. On this 10 kg mass, there is one force of 100 Newton acting towards right. Then there is a tension acting towards left because of string, and it has acceleration of 2 meter per second square. So net force is basically 100 minus t, and it is equal to ma. So mass is 10 into acceleration is 2. So 100 minus t is equal to 20, and therefore t is equal to 80 Newton. Okay. Weber, have you understood like how we got 80 Newton? Okay, okay, fine. Just give me a minute. Mm, okay. So similar to this for tension in the string, we have seen the questions on like normal reactions also, right? So I just want to take two more questions. I will solve the first one, and I will ask you to solve the second one, the second question on the normal reaction. Okay. So again, this is, let's say this is ground. Then there is a weight of, let's say, 10 kg. Then beside that there is a weight of, or sorry, mass of 5 kg. Then again there is mass of 10 kg. Then again there is a mass of 5 kg. And lastly there is a mass of 10 kg. And there is, on leftmost mass there is a force acting which is of 200 newtons. So let's say this is normal reaction between this. Let's say this is N1, this is N2, normal reaction between these two forces blocks. This is N3, and last one is N4. Okay. So so what they are asking is find the acceleration and normal reactions N1, N2, N3, and N4. Okay. So in this case also consider this whole as a system. So in this system, total mass of this system is basically 10 plus 5 plus 10 plus 5 plus 10. So it is equal to 40 kg total mass. Okay. And net force is acting towards right, and it is equal to 200 newtons. So therefore acceleration is force upon mass, which is equal to 200 upon 40, which is equal to 5 meter per second square. So on this system, basically whole system is moving with acceleration a meter, so basically, sorry, not a, 5 meter per second square. So now let's consider the free body diagram of leftmost 10 kg mass. So let's say this is the leftmost 10 kg mass. So there is a force of 200 Newton is acting on it. It is moving with acceleration of 5 meter per second square, and there is a normal reaction which is coming from the 5 kg mass, which is, let's say, N1. So net force is here 200 minus, since it is moving towards right, we will consider forces in right as positive and forces towards left as negative. So net forces is 200 minus N1 is equal to MA. So M here is 10, A here is 5. So we got 200 minus 50 is equal to N1, so which is equal to 150 Newton. Okay, so we got N1 equal to 150 Newton. So now we'll consider second mass, which is of 5 kg from left hand side. So let's say this is a 5 kg one. So here N1 is coming from left most block and N2 is coming from rightmost block, and it is also moving with acceleration of 5 meter per second square. So similarly we will write net forces, that is N1 minus N2 equal to M here, M 5 into acceleration 5. Here N1 is basically 150 Newton, so 150 minus N2 is equal to 25, and therefore N2 is equal to 125 Newton. Okay, let's consider third block. So it is again 10 kg block. On this block is also moving with acceleration of 5 meter per second square. There is normal reaction coming from right hand side, which is let's say N3, and from left hand side one normal reaction coming, which is N2. And the mass of this block is 10 kg. So again N2 minus N3, that is net force, equal to Ma. M here is 10, A is 5, which is equal to 50, and N2 is we found out as 125. So 125 minus N3 is equal to 50, and therefore normal reaction between this N3 is basically 75 Newton. Okay, and again we'll come to the fourth from left hand side, where the block is having normal reaction N4 from right side, normal reaction N3 from left side, and it is also moving with acceleration 5 meter per second square. Again normal force N4, sorry, N3 is positive here because N3 minus N4 is equal to 5 mass into 5 acceleration. N3 we got was 75 Newton, so N3 minus N4 equal to 25. So we got N4 is equal to 50 Newton. Any doubt in this solution, or you got the answer? Okay. Weber, what about you? Okay, fine. So I will give one similar question to both of you. I'll give 2 minutes to solve it. Try to solve this question as soon as possible because in exam you have limited time. Okay. We will have similar system. Let's say there are three masses. First one is 10 kg. Second one is also 10 kg. And third one is 30 kg. There is a force from left hand side, which is acting on first block. It is 200 Newton, and on third block there is force from right hand side, which is acting equal to 300 Newton. So now find out acceleration. And let's say this is N1, normal reaction between first and second, and this is N2, normal reaction between second and third. So find out these quantities. You have 2 minutes to solve this. Please try to solve it as soon as possible.
Sorry, you're muted.
Oh, sorry. So I was telling is like this is our total system, and net mass is 10 plus 10 plus 30, that is equal to 50 kg, and acceleration is 300 upon like net force is basically, see, 500 towards left, 200 towards right, so net force is 300 towards left. So net force is basically 500 minus 200, that is 300 newtons. So acceleration is force upon mass, so it is 300 by 50, that is 6 meter per second square, and it is acting towards left. Okay, now let's consider this 10 kg block which is on left hand side, 10 kg. Okay, so it is like reaction is happening, n1 is like this 200 newton this, and acceleration is in this direction, 6 meter per second square. So now if we see net forces n1 minus 200 is equal to mass into acceleration, that is 10 into 6. So we got n1 is equal to 260 newton. Okay, and now if we consider the middle block which is also of 10 kg, and there is acceleration of 6 meter per second square. So there is normal reaction n1, this normal reaction is n2. So net force is n2 minus n1 is equal to mass into acceleration. So that is 10 into 6. In this case, n2 minus n1 is here, 260 is equal to 6. Sorry, it is 6 meter per second. So it is 60. So n2 we got equal to 320 Newton. Mm, I think both of you got the different answer. Like, have you understood? Like, or you still have any doubt? Like, means, can I know like why you got 140 and 120? Is there any reason? What? Okay, okay. Please look at the directions properly because otherwise mm, it will give you wrong answers. So better to keep direction in mind. So now let's say we have two masses of both are having mass m kg. Let's say they are connected with a string. Okay, and there is tension T, and now they are basically free falling. Okay, under gravity. Okay, this is ground. They are falling from some height, and there is a string attached in between them. So what will be the tension in between these two masses? Can you solve this question? Since these two masses are attached with a string, they both are having mass m. So what is the tension in this string? Vertical upward or downward? It is moving vertically downward. Okay, it is free falling. Free fall means basically vertically downward. Okay. Okay, you got 2m g minus a, and Harini got t is equal to m into g minus a. Okay. So since I told it is both are like 1 second, my mic is okay. See, now you have these two systems, no, and both are falling under gravity. So now if you consider the first of all, if you consider the free body diagram of this mass m, so it is having some weight. So weight is, of course, it is acting in downward direction. And it is equal to mg. Okay, and tension is acting in upward direction, which is t. Okay, and since the it is moving downward, it is free fall, and since it is moving downward, let's consider forces in moving downward as positive, forces acting upward as negative. So basically net forces what we got from here are mg minus t, and it force is equal to ma. So net forces is equal to ma. So m here is will remains a, and you know that when anything is falling under gravity, the acceleration is basically acceleration due to gravity. So here ma will become mg only. So finally you got t is equal to mg minus mg, and it will be 0. So miss, your answer was correct, Harini. Like t is equal to mg minus a, but since acceleration is equal to acceleration due to gravity, it will become 0. Okay. So Vaibhav, any doubt like how we got this answer? So like when something is falling under gravity and there is a string attached, the net tension in this string, basically the tension which is there in string is 0. Okay, so you are asking mass will get added or not. So even if you add mass, okay, even if you add mass, what you will get, total mass is equal to m plus m, that is 2m. Okay, and why we add mass is basically we know F equal to ma, and we find acceleration of the system. So F upon m will give us acceleration. In this case, net forces are basically the weight of this, that is acting mg downwards, then mg of this weight of this second mass, which is mg downwards. So net force of this system, net force acting on this system is basically 2 mg. So mm, so here you got 2 mg upon 2m. So acceleration is basically equal to acceleration due to gravity, g, that is g. Okay. So once you got a equal to g, then we consider separate for like free body diagram for separate mass, right? So this is how we consider this free body diagram for this lower mass, or you can consider for upper mass also. So tension is acting in upward direction, weight is acting in downward direction. So net force is mg minus g equal to mass into acceleration, and where acceleration is equal to acceleration due to gravity, and it will become 0. Okay, okay, fine. Now let's consider more question on. Now you have this basically wedge, and this angle is 30-degree. Okay, and we have four masses which are on this wedge. Let's say first, this is first one, attached with string to other mass. Let's say this is second one. This is third one, and okay, this is fourth one. So this is basically 6 kg. This is 2 kg. This is 1 kg. This is 1 kg. So force acting towards downward side is 100 Newton, and force acting in upward direction is 200 Newton. So now find out acceleration. First of all, find out the acceleration, and let's say find out tension T1 and T2. Okay, once we find out any one or two, we can go ahead. So in this case, you know that so when there is a wedge, so these two are not the only external forces. First external force is 200 Newton, other external force is 100 Newton. So this is our system. But since it is at some angle to the horizontal, the weight of this uh, object is will also act as external force. Okay, so weight of this uh, objects in this direction basically will play a role in its motion. So let's find out first. So this is a 6 kg. So it's, let's say g is equal to 10 meter per second square. So basically 60 Newton force is acting downward. So we have to find out its component. Okay, so 60 kg. So if we draw this triangle, okay, this triangle, if this is 30 degree, this angle will become 90. Since this is 90, this angle will become 60 degree. Okay, and again if we draw perpendicular to this wedge, then this angle will become 30 degree. So the component of weight along this direction will be 60 cos 30, and the component of weight along this direction will become 60 sine 30, or you can simply write it as mg sine 30. Okay, so this will also act as an external force. Similarly, for this 2 kg block, there will be force of 2g sine 30. So here it was 6g sine 30, let's say 6g sine 30. Similarly, for this 1 kg block, force will act in this direction of 1g g sine 30. So g sine 30, and again here g sine 30. So these forces will also act as an external force. So now if we have to find out net external force, so let's say we find out, let's consider for just for now we consider forces acting in left as positive, forces acting as right as a negative. So if we find out net forces acting in this case, summation of forces, that will be equal to 200, which is positive, minus 6g sine 30 minus 2g sine 30 minus g sine 30 for third block, then minus g sine 30 for fourth block, and minus 100. So it will be equal to 200 minus 6 into 2, 8, 9, 10g sine 30, 10g sine 30. G is 10 into sine 30 minus 100. So sine 30 is 1 by 2, you know. So it will be equal to, see, let's say 200 minus this 100 is 100, minus 10 into 10 is 100, into sine 30 is 1 by 2. So that is equal to 50. So net forces acting in left direction is equal to 50 Newton. Okay. So net forces which is acting in left direction is 50 Newton. So from that we can find out the acceleration in this direction. So it will be equal to 50, that is force, upon mass. So here net mass is equal to 6 plus 2 plus 1 plus 1. 6 plus 2 plus 1 plus 1. So that is equal to 10 kg. So we got net mass is equal to 10 kg. So it is equal to 5 meter per second square. So the acceleration of this entire system, this system is basically getting accelerated at 5 meter per second square toward this direction. Okay. Okay. So now if you consider the 6 kg block. Okay. Now if you consider this 6 kg block, mm, just for a second, or we can consider it horizontal. Okay, no need to consider it vertical, just we will see the forces as horizontal and vertical. So let's say this is a 6 kg block. So forces acting towards right was 6g sine 30. So 6g sine 30, that is because of its weight. Okay, then there is tension T1 on left, towards left side, the forces acting equal to 200 Newton, and there is acceleration of 5 meter per second square. So basically if we balance the forces, 200 minus T1 minus 60 sine 30 is 6 into 10 into sine 30 is 1 by 2. So 1 by, if we divide 10 by 2 is equal to 5. So this whole term will be equal to 30. And this is equal to MA. M here is 6 kg and MAA is 5. Okay. So what we got is 200 minus T1 minus 30 is equal to 30. So mm if we solve this, we will get T1 equal to 140 Newton. In similar manner, we can solve it for T2 also. So just you will have to just consider the free body diagram of T2. So let's say this is T2, which is of 2 kg. So there is force. First of all, this is T2 is acting here. T1, sorry, T2 is acting like this. T1 is acting like this, which is 140 Newton. Then there is acceleration towards left of 5 meter per second square, and okay, T1 is T2 is like this, and there is mg 2g sine 30. So 2 into 10 into sine 30, which is because of its weight. So sine 30 is 1 by 2, so 1 by 2 and 2 will get cancelled, so it is 10 Newton. Okay, so if you find out net force, so in the direction of motion, so it will be T2 minus T1, which is 140, minus 10, and it equal to m as 2 into acceleration is 5. So what you got, T2 minus 150 is equal to 10, and therefore T2 is basically equal to 160 Newton. Any doubt in this question? Okay, I will give one similar way. Let's try to solve it. So now find out, first one is acceleration of the system and then tension. Okay. This is the question for you. Just try to solve it as soon as possible. Both mass are 5 kg. Force towards the right side is 1000 Newton. Towards left side it is 800 Newton. So please try to solve this question. 800, 800. Any answer from your side? Okay, okay, fine. Okay, no problem. Just write down the values. Okay, fine. I will start then. If I think you also got values, right, Vaibhav? You told, right? You T value is you are getting very high. Okay, fine. I will solve it. No problem. So this was the question. So force towards this direction is 1000 Newton on 5 kg and 800 Newton on this walk towards left side. Okay. So if you see this weight of 5 kg, then again you know that if this angle is theta, this angle is 90 minus theta, and therefore if you draw one more, this angle will also become theta. So forces which are acting uh, in the direction of motion because of the weight are basically mg sin theta. Mg sin theta. Okay, because this angle is theta, so this is 90 minus theta, so it is basically 37, so it is 53. Again, if you draw a perpendicular from here, so this angle will become 37. So the force along this direction will be the cos component, and along this direction will be sine component. Okay, so here it is 5g sin theta. Here also it is 5g sin theta. Okay, g is 10, of course. So 50 sin theta, sin theta. So 37 is the angle. Theta is 37. So therefore sin theta is equal to 0.6. So 0.6 into 50, it is equal to 30 Newton. Okay. So because of the weight of this object, the forces of 30 Newton is acting towards this. What we can say, it is basically southwest direction. Okay, 30 Newton. So now net force, if you consider this northeast direction as a positive, okay, northeast as a positive and southwest as a negative, then you can see that the net forces is basically 1000 minus 800 minus 30 minus 30. So it will be equal to 200 minus 30, 30 is 140 Newton. So net forces is towards northeast direction of 140 Newton. Now total mass is given as 10 kg, 5 kg plus 5 kg, that is equal to 10 kg. So acceleration is equal to 140, that is force upon mass, that is equal to 14 meter per second square. Okay. Now let's consider this right hand side uh, mass, which is 5 kg. So net acceleration is 14 meter per second square. Force which is pulling it is 1000 Newton, and there is a tension T, and there is one more for mg sin theta because of its weight, and we know that it is equal to 30 Newton. So again, if we do balancing in this direction, it will become 1000 minus t minus 30 will be equal to mass is 5 into acceleration is 14. So you got 970 minus t is equal to 14 into 50. So it is 70. Sorry, 14 into 5. So it is 70. So t is basically you got equal to 1040 Newton. You got this or still have any confusion? Okay, okay. Vaibhav, what was your answer? You told you are getting some higher value. Okay. Okay, then we'll take 15 minutes break and then we will meet at 6:35 exactly. Okay. Okay, I got it wrong or you got it wrong? Did I make any calculation mistake? Okay, okay, fine. Okay. No problem. We'll meet at 6:35. Okay. We'll take 15 minutes break. We'll meet at 6:35. Oh, okay, okay, got it. No problem. Okay. Okay, Vaibhav, are you there? Okay, we'll wait for her for 2 more minutes. Okay, I think she's also there. Okay. So now we will see about constrained motion. So, okay. So constraint means basically we are putting some limitation on the motion of the object. Okay. So putting limitations, constraint means putting limitations. So now we have seen like there was one object here of let's say 5 kg, one object of 10 kg connected with string, and let's say this is the force acting on this object. So we have seen that both if force is F is acting on this system, this whole system will move together. So if V is the velocity of this 10 kg block, then V is also the velocity of 5 kg block. If A is the acceleration of this 10 kg, A is also the acceleration of this. Otherwise, this string will break. So if 10 kg block starts moving, then the 5 kg block will also is also bound to move. Okay. So this is what is the constraint motion. Similarly, if you see the pulley arrangement, okay. So now if this side of rope moves by distance x, then of course this side will also move by distance x. So it is constrained. Like there is like if this left hand side of this rope moves by distance x in upward direction, then right hand side of the rope has to move in downward direction by distance x. So this is basically kind of constrained motion. So if we fix one parameter, other will get automatically fixed. So that is basically by mean of putting limitation on other one. It is not independent. Okay. So this thing you should note down. So earlier we have seen some tension, like how to find out tension in different kind of pulley and string arrangement. So let's say there is some mass attached here, there is some mass attached here, and since this is a single string, the tension in both sides will be same. Okay. So now and we have seen one more case last time. So there was one string. uh okay, 1 second, I will just, okay, sorry. Hmm. Okay, so this is same example only. So this was a tension T, and this will also equal to tension T because this is a single string. But this string is a different string, and if you apply the balance or equilibrium at this pulley, then you will find out this tension is equal to 2T. Okay, this we have seen in last class. Okay, so we'll just see one or some similar examples. So now let's say we have one more arrangement. Now find out the tensions in all these strings. Okay, so let's say if this tension in this string is given as T. So basically, if this is equal to T, then find out tensions in all the strings. If the question is like that, so if this is a T, then we know that this, since this is a single string here, here also the tension will be T. Okay, because this is a single string. And now if you see the force balance at this string, so it is basically T is going downward, one more T is going downward, and this is upward. So it should be equal to 2T. So therefore, in this string, the forces are equal to 2T. Again, if this tension is equal to 2T, then this is again a single string. So here also tension will become 2T. Now, again, if we see the free body diagram of this, we will basically see two 2T forces acting downwards. And so there is one upward force, and therefore this tension will be equal to 4T. Again, this string starts from here and ends here. And since it is a single string, the tension in this string will also become equal to 40, and therefore this tension will be equal to 80. Now coming down, if this single tension is 2T, and since this one is one string, so it has both same, it should have same tension. So again, if you draw this, it will become 40. So this must be equal to 2T and 2T. Okay. So you should able to find out the tension in a different string based on single value, because you know that first of all, you are applying two concepts here. First concept is tension in one string or single string is same everywhere. String is same everywhere. And second concept you are applying is force balance. Okay. So using these two concepts, you are you should able to find out the tension in different strings. Is it clear to you? Okay, okay, fine. Now let's consider one problem. So not a problem, but a sample example. So let's say this is a top. Then we have a bigger pulley here, and this object has mass m. Okay, just give me 1 second. Okay, and again these things come here, and there is a pulley here. This is going up. Again there is a pulley which is, let's say, connected at top. Again this string come down. There is one more pulley here. And here we have some other body. Okay, and the acceleration of this body is given as, let's say, some acceleration a. Okay, is given. So they are asking us to find the acceleration. We are not, let's say this is not mass, so we have to find out basically acceleration of this. Okay, so here we have almost One is bigger one, and one, two, three, four, five smaller pulleys. And so if the tension in this string is equal to T, let's say, so if this is T, this will also become T. This will also, this is single string, okay. This is also T. This is also T. This one is also T. Then this one is again T, and this one is again T. And now if you apply force balance as this pulley, you will identify that these tensions are equal to 2T, 2T, and 2T. Okay. So now you have seen this. Okay. So now, since this, okay, I should have used a different color. So this is a single string. We'll try. So this is a single string which start from this point, goes like this. This is a single string, and therefore at each place the tension is basically equal to T. Okay. And if we apply force balance as this pulley, this T is there, this T is also going upward, and therefore downward is basically equal to 2T. Okay. Because T was going up, here also T was going up. So now downward was equal to 2T. So therefore, in each this bottom string, the tension is 2T. So till now, is it clear? Okay. So here you should remember one thing. So here, if you see this object, if you see on left hand side, this mass, it is connected to one string. Like there is only T force, tension or force acting in on this. However, if you see uh, this mass, net force acting in upward direction is basically equal to 60. Okay. So here the net tension is T. Here the net tension is 60. So if A is acceleration of this bigger thing, then the acceleration of this smaller thing should be equal to 6A in this case. Okay. So it will just reverse. So if this has, since in this case the force or net force or tension was 60, so the acceleration was A, and in this case the force was T, and therefore the acceleration is 6A. So why it is so? So let's see. Okay. Now consider that first of all what we have learned in our uh, motion in class of motion in straight line, or maybe yeah, that velocity is basically equal to dx upon dt, that is rate of change of displacement, and acceleration is equal to double derivative of displacement. Okay. So now first thing you should remember, like here, since here tension is T, so and here tension is 60, so here if acceleration is A here, then acceleration is 6A here. So why is it so? So if this, consider, see, I will draw one more figure so it will be much clear to you. So these top pulleys are fixed. Okay. This bottom pulleys can move. These pulleys can move. And basically they are connected to a mass which is having acceleration A. Okay. Now, if this mass moves certain distance, let's say x, if this mass moves certain distance x, so since if it moves distance x, then see, then of course, these three pulleys will go upward. Okay. And see, this rope is covering how means moving like this how many times? This is one, this is two, this is three, this is four, this is five, and this is six. So basically, these three pulleys, if these three pulley moves x by six, okay, like this is their initial position, okay, and if each pulley moves x by six, all these three pulley, then this rope like miss here you will see that the let's say initial distance was L. Okay. Initial distance of this height from this point to let's say this center was L. So if this pulley move upward by L by 6, sorry, x by 6, then the final distance will be equal to L minus x by 6. Okay. Similarly, if this earlier initial distance between these two pulley was let's say L1. So after this pulley moves by x by 6 distance, the final distance will become x minus L by 6. Similarly, this distance will also become L minus L1 minus x by 6. So this is how if you see the initial minus, if you do initial minus final, that will be equal to x. So if these three pulleys moves x by 6, then the total length of this rope that will come down will be equal to x. Mm, like any question, or you want me to explain this part again? Okay, okay, I will explain it again. Okay, I will draw it to more diagram that will be much easier to understand. Okay, so this is the initial position of this our system. Okay, so now this distance from this point to this point is let's say L1 or let's say L, and this distance, all of these distances are basically equal to L1. This, and it is same only. Okay, you can clearly see this, that this height is basically from this point to means the distance between center of this pulley is basically equal to L1. And okay, so now if you have to find out total length of the rope, okay, we will eliminate the length of the rope, which is uh, around its circumference for time's sake. Okay, so if we have to find out total length, it will be this length from this point to this point. It is L. Then from this point to this point, it is L1 plus L1. Again from this point to this point, again plus L1. Then from this point to this point plus L1. Then this point to this point plus L1, and again from here to here. Okay. So how much is the length of the rope? Initially L1 plus 5, sorry, L plus 5L1. Okay. This is the initial uh, what initial length of the rope in between, like from point this point to this point. Now if we mm, you understood that the length is L plus 5L1 till now, like how length of the rope is L plus 5L1. Till now that you got this? Okay, okay, fine. Now these three pulleys have moved upward by distance of x upon 6. Okay, x upon 6 means let's say initially they were at this point. So this length was given as L. But now these three are movable pulleys and they have reached to this point. And this distance by which they have moved is x upon 6. Okay. So now this point to this point, distance is L minus x upon 6. And initially this distance was L1. But now this distance is in between these two center of this pulley is L1 minus x upon 6. So now this distance is now from point this, let's say this is A to point B is plus L1 minus x upon 6. Now from, let's say this point is C, this point is D, so that is also plus L1 minus x upon 6. Similarly, from, let's say this point is E, this point is F, so from E to F is also L1 minus x upon 6 plus, let's say this is G, this is point, this point is H, then this is L1 minus x upon 6. And last, this, let's say this is I and this is J. So I to J, distance between I plus J is also L1 minus x upon 6. So what we have done is these three pulleys have moved by distance x upon 6 in vertical direction. And therefore, the new length of rope what we got is, let's keep it as it is, like L, L1, L1. So it will remain as it is L plus 5L1, and x upon 6 is 1, 2, 3, 4, 5, 6. So it is basically equal to minus x. Okay. So this is new length of rope. Okay. So if the length of rope initially it was some L plus 5 L plus 5 L1 from this point, let's say this point is 1 and this point is 2. So length of rope between 1 and 2 was L plus phi L1 initially, and now it has become L plus phi L1 minus X. So this basically this rope has, if the initially this block was at this point, so it has moved by distance X, because now the length of rope has become L plus phi L1 minus X. So that X will get added here, and this block, whatever it was its initial position, it will move down by distance X, because rope will always be there, no, that it will not go, or it will not what uh, I don't remember the word, but means if the initial length is L, then the total means if there is some initial length of that rope, the total length will, of course, it will remain constant. So if the what if the distance of rope from 1 to 2, so this point was 1 and this point J point is basically 2. If it has reduced by distance X, it will get added. So let's say if this was 3 to 4, this was 3 to 4, so it will get added into 3 to 4. Okay. So what it tells is, if this block on left hand side, if this block moves by distance X, then these three pulleys have moved by distance X upon 6. Okay. So when this block is moving by distance X, these pulleys are moving with distance X by 6. So distance, or basically displacement. So its differentiation, first differentiation is velocity. So it is dx upon dt, and its first differentiation is 1 upon x dx upon dt, and its second differentiation is acceleration, is d square x by dt square, and its acceleration, its second derivative is acceleration, which is 1 upon 6 dx upon dt square. So what earlier we have seen is tension. If T was the tension here, or tension acting on this object, then net tension acting on this object was 60. Okay. And if this was 60, and if it is having acceleration a, then the acceleration of this block is 6 times its acceleration. Since now the acceleration of this block is d square x by dt square, and for acceleration of this bigger was 1 upon 6 d square x by dt square. So therefore the acceleration of the smaller one is 6 times higher than the acceleration of bigger one. Okay, you got it, or still have some confusion? Okay, okay, fine. Just give me 1 second. Okay, we'll see one question based on it. So let's say in this case, if the acceleration of this block, bigger block, is given as, let's say, some value 50 meter per second square. So we have to find out acceleration of this smaller block. Okay. So you know that tension, since this is a single string, tension will be same. Whereas if you draw equilibrium diagram here, you know that this will become 2t. Okay. And here also it will become 2t. So net force in net tension on this block is basically t, and here on this block it is equal to 40. So if this is having 50 meter per square acceleration, this will have acceleration of 50 into 4, and it will be 200 meter per second square. Okay. And that you can identify from one more thing. So if length will change, this is like L1, 1, 2. So here 1, 2, 3, 4. So basically, if this block moves by distance x, this two pulleys will move upward, or this block will move upward by x by 4, and that you can clearly see from our earlier concept, and therefore its acceleration will be 4 times the other acceleration. Okay, you got it, like how we can solve this type of questions. Okay. What happened, Vaibhav? You have some doubt? Okay, okay, fine. So we will see some questions on this kind of uh, pulley and mass arrangement. And okay, so let's say this, there is a pulley which is attached to two different means with attached to two different object with the help of a rope. Okay, let's say mm, this angle is theta 1, and this angle is theta 2, and this velocity is v2, and this object is moving with velocity v1. So basically find out relation between v1 and v2. So in constraint motion, what we have seen, since this is a single string, okay, so if this part of this string is moving with velocity u, then this part is also moving with velocity u. If this part is moving with velocity u in this direction, then this side is also moving with same velocity in other direction. If the velocities are different on either side, then of course it will break. So this is the thing we have learned, like the velocity will be same on both the side, or for a single string the velocity should be equal at all the locations. Okay, so therefore if we have to equate these two things, what we can simply do is we can find the velocity component of like this object v2 along this direction, and velocity component of this second object or first object. Let's okay. Okay, so velocity, let's say this is the first object, this is second object. So basically, velocity component of this first object along this direction should match with velocity component of second uh, object along this direction, because of course the velocity of string cannot be different. Okay, so therefore you know that, like, now we have v2. Let's say this is v2, this angle is theta. So component of v2 along this direction can be basically given as v2 cos theta. Okay, similarly this angle is given as or cos theta 2, because this angle is here theta 2, whereas this angle is given as theta 1. So velocity component of v1, so since this is theta 1, this is theta 1, this angle is also theta 1, and we have to find out the velocity component of v1 along this direction. So therefore it is also equal to v1 cos theta 1. So therefore, since velocity along the string is constant, so v1 cos theta 1 is equal to v2 cos theta 2. Okay, you got it? Like how, why these velocities are equal along this string? Okay, okay, fine. I will explain it again. See, now if you take one rope, okay, there is a rope. Let's say it is having point A and B. Now some person comes, he hold the rope at point B and starts moving at velocity. Let's say, okay, there is a person who is holding this with his hand, and he starts moving with velocity v meter per second. If he moves like this, it is his hand, then of course all the point on this rope will move in same velocity, with same velocity, right? All point on this rope will move with v meter per second only. Correct? You understand this, like why all point on this rope will move with same velocity? Okay, so similarly, now if you have attached, this is what is the definition of this mm, what we say called constrained motion. So if this is the rope now, okay, if this point is moving with velocity 1 meter per second, then this point will also move by 1 meter per second in this direction. Okay, because if it is not moving its same velocity, then distance covered by this will be, these two strings will be different and it will break. So both should have same velocity, right? If this is moving, this side is moving with velocity 1 meter per second towards this direction, then this side will move at same velocity 1 meter per second in this direction. You understand this? Okay. So therefore, for this string, like basically the, So now this end of this string is moving with velocity v2. This angle is theta 2, and this end of the string is moving with velocity v1, and this angle is theta 1. So basically this velocity along the string and this velocity, those two must be same. So component of v2 along this direction is basically v2 cos theta 2, and the component of v1 along this direction is v1 cos theta 1, and therefore they must be equal to each other. Got it? Or still you have some confusion? Okay, just give me 1 minute. Okay, I'm getting one important call. I will Okay, so sorry for the inconvenience. So we will see similar question, one more similar question. So let's say now there is a wall. So this is a wall, okay. So this is wall, and there is a rod which is resting against, not resting, basically it is moving against wall. Okay, this is the wall, and this angle is theta. So this rod is moving at velocity u in horizontal direction. Okay, so and this end of the rod is moving with velocity, let's say v. So let's find this what correlation between u and v. So you know that, like, even though all the two ends of the rods are moving at different velocities in different direction, but like all point, since it is a single rod, the velocity of this rod is same at all the points. Okay, and therefore it is a single rigid rod, therefore velocity is same across all points. So therefore, if we have to find out relation between u and v, what we will do is we will find out the velocity component of along this direction of rod. Okay, so this angle is theta, so this angle is 90 minus theta. So so velocity component of v along this direction of the length of the rod is v cos 90 minus theta, and it should be equal to the velocity component of u along the length of the rod, that is equal to u cos theta. And you we know that cos 90 minus theta is basically cos a minus b. So cos a minus b is cos a cos b, cos a cos b plus sin a sin b. Okay, and we know that cos 90 is 0, so this whole term will become 0, and sin 90 is 1, so cos 90 minus theta is basically sin theta. So here we got v sin theta is equal to u cos theta, and therefore v is equal to u upon tan theta. So this is how we should able to correlate them. Okay, any doubt in this one, like how we have found out the relation between u and v? Basically you should know that we are basically uh, we know that the velocity across this length of this rod or across the length of the rope is constant, so we just try to match it. Okay, okay, we'll see some examples. Okay, let's say we have a pulley, and there are two masses. Let's say this one is m1 and this one is m2. So find out T as well as A. So T is tension, A is acceleration. So T is tension, A is acceleration. So we know that since it is a single string, the tension along this basically string is constant and it is equal to T. So now let's consider the FBD of M2. Okay, let's say that it is moving in this direction, and since it is a single string, if it is moving at some acceleration a, the other mass is also moving at acceleration a, because it is single string, it will move at same velocity, same acceleration, and both will have same displacement also. Okay, because it is a constrained motion, if one moves with some velocity, acceleration and displacement, other will also move with same velocity, acceleration and displacement. Okay, so for F2 M2 we have tension acting in upward direction, then it is moving at, let's say, acceleration a, and there is M2G acting downwards, that is weight. Okay, and one more thing is like, okay, fine. So if we do force balancing, since it is moving in downward direction, forces in downward direction, let's consider positive, forces in upward directions are negative. So what we got is M2G minus T is equal to M2 times A. This is the first equation we got. On the other hand, for mass M1, now here, since the M2 is moving downwards, M1 will move upward. So for this one, let's consider forces in upward direction as positive, forces in downward direction as negative. Okay, so this is T, this is M1G, which is acting downward, and it is a acceleration A. So again, if we do force balance, we get T minus M1G is equal to M1 times A. So now if we so from this we can find out T is equal to M1 A plus G. Okay, because this M1 G will go on other side, M1 will become common, and A plus G will be in bracket. So if we insert this into equation number 1, let's say this was equation number 2 and this is equation number 3. So if we insert equation number 3 into equation number 1, so it will give us M2G minus M1 into A plus G is equal to M2A. So from this we can find out the acceleration. Let's find it out. So M2G minus M1A minus M1G is equal to M2 times A. Let's take this term on the right hand side. So here what we got, M2 minus M1G is equal to M2 plus M1 into A. So the value of acceleration we got is basically A is equal to M2 minus M1 times G divided by M2 plus M1. So this is how we have found out the acceleration of this. Then if you put this acceleration into the equation number 3, so equation number 3 was M1 into T is equal to M1 into A plus G. Okay, so now if we put value of acceleration into this, we will get T. So T is equal to M1 into, so your acceleration is M2 minus M1 upon into G into M2 plus M1 and plus G. So we'll take G as a common. So what we got is T is equal to M1 G into M2 minus M1 upon M2 plus M1 plus 1. So finally we got T is equal to M1G. Now M2 minus M1, we will make their denominator common, so it will become M2 plus M1, and whole denominator will be M2 plus M1. So M1 will get cancelled. So finally we got T is equal to C, and here we got 2M2. So 2M1 M2 times G divided by M1 plus M2. You guys understood how we found out acceleration as well as tension in this case? Okay. So we can simplify this problem in another manner. Okay. So the question was, this was the pulley. Okay, this was the M2, this was the M1. Okay, so and we know that there is a for or weight of this is acting downwards. This was M2G, weight of this was acting downwards, M1G. So this was single pulley system with two masses, so you can directly make it horizontal. Okay, and now let's see, this is M2 and there is a force acting towards left, that is M2G. Then there is a string which is having tension T, and then there is M1 here and force of M1G acting towards right. So we can simplify this problem as this next whatever I have shown. So net force, let's say if whole system is moving towards this, net force acting is equal to M2G minus M1G. Total mass of the system is M1 plus M2. So total mass. Okay, so acceleration is basically force upon mass. So if we take G common, we what we will get M2 minus M1 into G divided by M1 plus M2. So we have just converted this problem from vertical to horizontal. Okay, so and now if you take the FBD of mass 2, so we can draw it as this was M2. So there is a force M2G acting towards left, then tension is acting towards right, and there is acceleration A. So from that we know that M2G minus T will give us M2 into acceleration. So acceleration we found as M2 minus M1 divided by M1 plus M2 times G. Okay, so therefore tension will become equal to M2G. We'll take M2G constant and it will become M2G 1 minus M2 minus M1 divided by M1 plus M2. Sorry, this is only to this second term, M2, M1 plus M2. Okay, and if we solve this, we will get M2G M1 plus M2 minus M2 and minus M2 minus plus M1 divided by M1 plus M2. So here M2 got cancelled and we got 2 M1. So finally we got tension is equal to 2 M1 M2 G upon M1 plus M2. So just what we have done is this vertical like weight we have considered as horizontal force, and we have converted this problem from vertical to horizontal and we got same results. Okay. Any doubt in this? Like we understood like how we have converted this vertical problem into horizontal one, and it became much easier to solve because we found acceleration very easily in this case. Okay, so we will see two more cases for same thing, like how we should solve that. Just 1 second. Okay, again we have a system. There is mass m1, there is a pulley here attached. So this is mass m2. Okay, so in this case we know that, like in this case, again if we have to find out, this tension will be same because it is a single string T. Okay, so for FBD1, let's say for mass 1, mm, let's say this is moving downward, okay, with acceleration a. So this one will move horizontal towards right with acceleration a. So for first mass, the if we draw FBD, it will be like there is tension T here acting in this direction. Then there is no horizontal force other than tension. Okay, so the other is basically acceleration. So net force is T, which is equal to m1 into a. So that is first equation. For second mass m2, we have T acting upwards, we have mass weight acting m2g downwards, and then there is a acceleration. And since it is moving downward, we will consider forces acting in downward direction as positive, forces acting upward direction as negative. So what we will get here, m2g minus t is equal to m2 into a. So in this case, if we put now t is equal to m1a, what we will get, m2g minus m1a is equal to m2a. So therefore, if we take if we move this term towards the right side, what we will get, m2g is equal to m1 plus m2 into a. Okay, and therefore acceleration is m2, sorry, m2g divided by m1 plus m2. And if, from this first equation we got tension is equal to m1 a. So if we put acceleration here, what we will get, tension is equal to m1 m2g divided by m1 plus m2. This as a tension. Okay. Similarly, if we go and consider the make this problem horizontal in a similar manner, okay, then how it will become is, it will again become, there is block m1, there is a string with tension T connected to block m2, and there is force m2g acting towards right side. So from this what we got is, net force acting is m2g, net mass of the system is m1 plus m2. So acceleration is force upon mass, so that is basically equal to m2g divided by m1 plus m2. Now if you draw the FBD of mass 2, let's say it is having acceleration a and tension T in opposite direction, and m2g force in right hand side. Since it is moving towards right, we will consider forces in right as positive. So m2g minus T is equal to m2 into a. And now if we put here, so basically T is equal to m2g minus a. Now if we put a as m2g upon m1 plus m2, then we will get m2 into g minus m2g divided by m1 plus m2. That will give us m2 into, we will multiply both sides by like on multiply g by m1 plus m2 to make denominator same. So m2g minus m2g divided by m1 plus m2. These two terms will get cancelled with each other, and we will get tension is equal to m1 m2g divided by m1 plus m2. Again, any doubt in this problem till now? Like, you got it how we have solved this one also? You can make it horizontal and it will be really simplified actually. Okay, okay. We'll see one more case. Oh my God. Now here we have a pulley, then there is a mass m1. This angle is theta 1, this angle is theta 2, and there is mass m2. So in this case, find out. So since it is a single string, tension will be same. Okay. So in this case, find out tension. So we know that if this is the mass, then weight will act in this direction. Okay. Similarly, for this one, weight will act in this direction. So if this angle is theta, and if we draw one horizontal from here, if this angle is theta, and let's say this is 90 degree, because this line is perpendicular to this wedge. If this angle is theta, then this angle is also theta, because this angle is 90 minus theta, and the remaining angle is again theta 1. So the component of weight which is acting in the direction of motion of this mass is basically m1g sine theta 1. Similarly, in this case, it will be acting towards this, and it will be m2g sine theta. Okay, so we have reached up to this point. Now let's say m2g sine theta 2 is more. So objects are moving in this direction. This is the a is the acceleration. So now if we draw the FBD of this mass m2, then we have acceleration a, then force m2 g sine theta 2, and there is tension T. Okay, so this mass is m2. So since it is moving in the right side, we will consider forces in the right hand side, towards the right side, are positive. So m2 g sine theta 2 minus T is equal to m2 into acceleration. So this is equation 1. Similarly, for the mass 1, it is moving in this direction, acceleration, tension also is in this direction, whereas this component of weight is in opposite direction, sine theta 1. So from this we got T minus m1 g sine theta 1 is equal to m1 into a. So this is what our equation number 2. Now if we find out T is equal to, if we take m1 common, we basically get a plus g sine theta. So this is what is T. So this is equation 3. So now if we insert this T into equation number 1, what we will get is m2g sine theta 2 minus T. So T is basically m1. Let's open the bracket, minus m1a minus m1 g sine theta 1 is equal to m2 into a. We'll take this towards right hand side. What we will get is, let's take g common. So we'll get m2 sine theta 2 minus m1 sine theta 1 is equal to m1 plus m2 into a. So acceleration is basically g into m2 sine theta 2 minus m1 sine theta 1 divided by m1 plus m2. So now if you put this value of acceleration into equation number 3, what we will get is T is equal to m1. It is a plus g sine theta. Well, I will write down first. A plus g sine theta. So if we put now the value of a, so what we will get is T is equal to m1 into big bracket g m2 sine theta 2 minus m1 sine theta 1 divided by m1 plus m2 and minus g sine theta basically. So we'll take g outside. Okay, g sine, okay, not just g sine theta, it was g sine theta 1. So it was g sine theta 1, g sine theta 1. Now we will make the numerator denominator same and we'll take g outside. So what we'll get is m1g m2 sine theta 2 minus m1 sine theta 1 minus m1g, sorry, g we take have taken out m1 sine theta 1 minus m2 sine theta 2 upon m1 plus m2. I think I have made some mistake. I think I made some calculation mistake. Okay, let's first solve this. We'll see what we get. We got m1 g divided by m1 plus m2. m2 sine theta will get cancelled with m2 sine theta. And okay, okay, I'll see it again. I think I have made I think some mistake. So for second object, okay, m2g sine theta was acting towards right. So m2g sine theta minus t is equal to m2a. Okay, this equation is correct. The second equation is t minus m1g sine theta 1 is equal to m1a. This is also correct. So what we got is t is equal to m1a plus g sine theta 1. Okay, now if in equation number 3, equation number 1, if we put this, so what will get m2 g sine theta 2 minus m1 into a minus m1 g1 sine theta 1 is equal to m2a, correct. So if we take g outside, we get m2 sine theta 2 minus m2 sine theta 2 minus uh, m1 sine theta 1 is equal to m1 plus m2 into a. Okay, it looks correct only. Then t1 is equal to t is equal to m1 into a plus g sine theta 1. So here a is basically g m2 sine theta 2 minus m1 sine theta 1 divided by m1 plus m2 minus g sine theta 1. So okay. So it is m2 sine theta 2 minus m1 sine theta 1 minus m1 sine theta 1 and m minus m2 sine theta. It is also sine theta 1. m1 sine theta 1 minus m2 sine theta 1. So finally what we got is it is basically minus 2 m1 plus m2 sine theta 1 divided up by m1 plus m2. So this will get okay. I think this is again I made mistake. So in this case, this m2 sine theta 2 will remain as it is. m2 sine theta 2 will remain as it is. m1 sine theta 1 and m1 sine theta will uh, okay, it was minus 2 m1 sine theta 1. Oh, just give me a second, okay? I will erase this. Okay, so what we got t is equal to m1 is outside and let's take g also outside. So what we got here is m2 sine theta 2 minus m1 sin theta 1 minus m1 sin theta 1 minus m2 sin theta 2 divided by m1 plus m2. So E minus m1 g sin theta equal to m1 into a. Okay, m2 g sin theta 2 minus t is equal to m2 into a. Okay, so I think just wait for a second. Okay, we will try to make it horizontal and solve this, and I will check whether I think I'm doing some positive negative mistake. I'm not able to find it out. Let's see. Let's make it horizontal. This was m1. Force was m1 g sine theta 1, and acceleration was in this direction a. Then there was a tension e, and there was m2. In m2 there was force m2 g sine theta 2. This was sine theta 1. So in this case, net force, if we have to find out, it is m2 g sine theta 2 minus m1 g sine theta 1, and net force is equal to, basically, if we take g constant, m2 sine theta 2 minus basically f minus m1 sine theta 1, and net mass is m1 plus m2. So acceleration here we got is g m2 sine theta 2 minus m1 sine theta 1 divided by m1 plus m2. Now let's consider free body diagram of first mass. So in this there is tension T acting there, then there is acceleration A, and there is force m1 g sine theta 1. So if we balance this, we will get T minus m1 g sine theta 1 is equal to ma. Okay, so T is basically equal to m1 g sine theta 1 plus ma. Now if we put, instead of acceleration, if we put this term g sine m2 sine theta 2 m1 sine theta 2 upon m1 plus m2, then we get T is equal to m1 g sine theta 1, okay, plus, this was also 1, m1 into g m2 sine theta 2 minus m1 sine theta 1 divided by m1 plus m2. Okay, so now let's try to make their denominator same. So we will multiply the first term with m1 plus m2. So we will get m1 square g sine theta 1 plus m2 square g sine theta 2, sorry, theta 1 only, m2 square, or sorry, not m2 square, it will be m1 m2 g sine theta 1 plus, again this multiplication will give us m1 m2 g sine theta 2 minus m1 square g sine theta 1, and whole term will be divided by m1 plus m2. So this term will get cancelled, and finally what we will get is m1 m2 g sine theta 1 plus sine theta 2 divided by m1 plus m2. This is the value of tension we will get. Actually, we should get same answer using other equation also. I will just check what mistake I am doing in this case. So if we draw the FBD of this now mass 2, what we will get is force is m2g sine theta 2. T is in opposite direction and acceleration is like this. So basically m2g sine theta 2 minus T is equal to m2 times A. So T is basically m2g sine theta 2 minus m2A. So it is equal to m2g sine theta 2 minus A. Whereas m2g sine theta 2 minus A, okay, and T is equal to m1 A plus g sine theta 1. T is equal to m1 g sine theta 1 plus m1 A. Okay, both equations are same. Then acceleration is also mm, what acceleration we got is g m2 sine theta 2 minus m1 sine theta 1 upon m1 plus m2. Whereas in other case, what we got acceleration g m2 sine theta 2 minus m1 sine theta 2 upon m1 plus m2. Then what mistake I was doing? Can you able to point it out, like what mistake I am doing in this solving this one? I'm not able to figure it out. Oh, okay, okay. I'm sorry. I'm sorry. I'm sorry. Here this is plus g sine theta 1. So, okay. If this is plus g sine theta 1, then this term will become plus m1 sine theta 1 plus m2 sine theta 1. So m1 minus m1 sine theta 1 will get cancelled with this one, and finally we'll get same answer. Okay. Sorry, I think there was positive and negative. Okay. Okay, fine. So you got it now, like how we have arrived at the final answer. I'm I lost one minus sign and then I okay, fine, okay. So I think we have taken a lot. I think it is 8 o'clock. We'll just take one or two example and we'll stop. Okay, is it fine for both of you, or you have something? I can continue, right? It will take 5 minutes. It, oh, oh, okay, okay. 5 minutes are also not possible, like to extend by 5 minutes. Vaibhav, is it fine for you? Okay, okay, okay. So we'll just see the some examples. Okay, so let's say there is a pulley, uh, and okay, we'll draw one more time. There is some issue. Okay, so one is mass small m, and other is mass 4m. So find tension in the string. Okay, so best way to solve this, you know that we can make it horizontal, and force acting here is mg, here force acting will be 4 mg. So if you make it horizontal, there is m, and both are connected with string with tension T. Other is 4m. So in this case, on this left hand side force acting mg, on this right hand side force acting 4 mg, because we made it horizontal, horizontal. So net force is acting 3 mg on this system. On this system, net force is acting 3 mg in this direction. Therefore, this system will move in this direction. So acceleration will be equal to force upon mass. Net mass is 4m plus m is 5m. So acceleration will be equal to, what is force here? 3 mg. Net force is 3 mg divided by 5m. So basically it is equal to 3g upon 5. Okay. If it is 3g upon 5, let's consider FBD of this 4m mass. So there is tension T acting here. There is force 4 mg acting towards right and acceleration A. So basically you will get 4 mg minus T is 4m into acceleration is 3g by 5. Okay, into 3g upon 5. So this is how you can find out T is equal to basically 4 mg minus 12 mg by 5. 12 mg by 5. So this is your final answer. So 20 minus 12 is 8 upon 5. So it is 8 upon 5 mg. So, okay. So basically what we have done is we have made the vertical problem into horizontal. Similarly, you can do it for other cases, like even if they gave you wage, or even if they gave you uh, what, one is horizontal and one is vertical. Okay, we'll see the last question now. So we can, this is previous year question. Okay. Mm, so this is the block. Here we have two pulleys. Okay, one pulley here, another pulley here. There is a mass of 4 kg. Then there is a rope, and here you have 10 kg. And on other hand, there is one more pulley, and here it is 6 kg. So we know that we have two strings here, and therefore let's say this is T1 and let's say this is T2. So tension in both the strings will be different. And as you can clearly see that, like on the right hand side, the weight is hanging, which is 10 kg. So we can simply assume that it is moving in this direction, or you can simply make it horizontal. So if you make it horizontal, it will be like force of 10 g is acting downwards. Here the force of uh, 6g is acting downwards. So if we make the diagram, it will be 6 kg attached with a string with tension T1. Then there is 4 kg. Then it is attached with string with tension T2, and it is 10 kg. Okay, and here force is acting is 10 gravity, 10 times gravity, acceleration due to gravity. Here 6 times acceleration due to gravity. So if you see it clearly, net force is 10 minus 6, that is acting towards right, 4 times acceleration due to gravity. Force is, you got force as 4g. You know total mass is 64 into 10. 64 plus 10 is 20 kg. So acceleration is 4 times acceleration due to gravity divided by 20. So it is g upon 5. Okay. Now if you consider any of the mass, it is, let's say it is 10 kg mass, tension is towards left, and force is 10 times gravity is acting towards right. There is acceleration a. Okay, which is g upon 5. So we basically can write 10g minus 10 is equal to mass, which is 10, into acceleration a, which is g upon 5. So it is 2g. So finally we got t is equal to 8g. T is equal to 8g, and acceleration a was g upon 5. So just make the vertical problem horizontal, and it will become easier for you. Okay. So